Okay, so this is from the Open Auto website. I just wanted to show you some stuff. So I'm using the latest beta, and it's actually RC1, so it's actually a release candidate. So they actually have support for external GPS module, which means that they'll probably also support external maps really soon, which is really cool. Because again, if you want this to be a head unit replacement, then ideally you can run anything without actually having to have a phone connected to it. So that's really great, because especially for iPhone users, right? Obviously, Android Auto is not a solution for people that use iPhone, but so this is one step closer to that. So, and it says here to activate the external Bluetooth dongle, you just type sudo bt switch external command, and that's it. So I'm going to go ahead and do that right now. So there it is right there, sudo bt switch external, done. Okay, current variant says it's internal, so now I'm switching to external. Because again, I've got that Panda Bluetooth adapter already connected, so it's going to switch from internal to external. So now it's telling me to restart, enter. It's rebooting, and I also want to show how fast this thing reboots, because I haven't shown that yet. So it's about 15 seconds, I would say. It's really fast. So there it is right there, and just gotta wait for a second. And then that's it. It's booted up now. So, and then there it is right there. So now let's do some tests. I want to make a phone call and see if it actually works. Before I make a phone call, I just want to show something. Obviously, before you can do anything with this thing, right, you actually got to pair it with your phone. So see that little symbol right there? That's showing that the BT is in pairing mode. It stays in pairing mode the whole time unless you tell it to do otherwise. So that's great, because then if you want to pair it with your phone, you can do it at any time. You don't have to do anything extra to do it. So I'm going to go ahead and pair my phone. It comes up as Open Auto. I think Open Auto Pro or Open Auto or something like that. It's really obvious. So I'm going to go ahead and pair my phone with the unit now, and then I'm going to see if I can make a phone call and play some music, even though it's not really, that's just an extra nice little thing to have. Okay, so now my phone is connected. My phone is a V30, and right now I'm using an iPhone just so I can use the phone separately. So there's my phone sitting there. It's not connected to anything. The thing is that it actually detects my contacts and my call history and all that. It paired up really nicely. So in order to test it, I'm actually going to call myself and leave myself a voicemail. So I'm going to go ahead and do that right now. I'll go ahead and turn it off and turn it back on when its voicemail starts, just so I can play it back.
I'll get back to you as soon as possible. Thanks. Bye.
Record your message after the tone.
So obviously the audio is working.
Done. Or for delivery options, press the pound sign.
Hey, this is Richard with Automate Everything. I am just testing to make sure that the audio works. So obviously I can hear a sound, but can it actually record sound well? Let's find out. Okay, I have a new voicemail, so let me go ahead and play that voicemail back in my car. I should be able to hear it. Let's see.
Hey, this is Richard with Automate Everything. I am just testing to make sure that the audio works. So obviously, I can hear sounds, but it actually records sound.
Okay, so you could hear that. It worked pretty damn good. It sounded a little bit further away. I could probably adjust the position of the microphone, but I was actually, the old microphone that I was using was absolutely terrible, and in a recent update, I actually updated for a higher quality microphone. This thing still, it was like 15 bucks. It was really cheap. So that's perfectly adequate for voice calls, and the best thing about it is that it's all going through the Pi, so no longer having to worry about like the audio for my voice being way lower than the audio for my car, because that was the issue using the external adapter. I am really happy with this, so that's great. So that worked. Now let me just see something here. So this is just streaming. So say if I don't want to connect my my phone, I just want to stream Bluetooth. See what happens. So here, I don't know what that is, but let me go ahead and actually like fire something up here. Okay, so that's coming up. The volume for my Bluetooth is actually really low. So there it is right there. I don't know, this doesn't actually have any album art to it. Let me see if something with album art actually works. Okay, so unfortunately album art doesn't work. So see on my phone, there's the album art. Here I hear nothing, or I see nothing, but who cares, right? I mean, I'm driving. The Bluetooth streaming audio works really well though. So I'm not in Android Auto or anything, I'm just streaming. And again, this is without an external adapter. This is going through the Bluetooth on the standard wireless. So I love me some metal, dude. Hell yeah. Anyway, next. And here I am, starting on trying to get the steering wheel controls working. So I did say in my first video I was actually going to make sure I tried to get the steering wheel controls working. And 6 months later I finally got around to doing it. So I have two wires here that are coming from my steering wheel. One wire is the wire that comes directly from the resistive ladder. So I'll show up the schematic here in a little bit just so you guys can see what I'm talking about. And then the other end is really just the other end of that resistor ladder. So the two wires, I spliced into it through my wiring harness, and now I have it going into a little Arduino that I paid like 10 bucks for. An Arduino Leonardo. I don't even know if it was 10 bucks. I mean, it was dirt cheap. So what we have here is, I just want to show you here. So kind of the first end of the resistor ladder. Man, I cannot get that thing to focus very well. I'm trying here. But that red wire, that is the incoming wire for the resistive ladder. And that is going to 5 volts. The other wire, so in there I have a resistor that is really just a voltage divider. And all I did to figure that out, I just went to the Arduino website and I said, how do I wire an analog input? And that's what it told me to do. It told me to put a resistor in series, so that's what I did. So that is a 1K ohm resistor. That is going to the, there we go, there, now it's focusing. So you can see that's going to the ground. And on the other end of that resistor, I've got the ground from the resistive ladder on my steering wheel controls, and I have that wired together in parallel with the analog input A3. That's just a random one. So what you can see here is you've just got a bunch of data coming in. So this is what it looks like when I don't press a button. And really all this is reading is the resistance coming in from my resistive ladder. So if I don't push any buttons at all, it reads 317 ohms. So I'm going to push a button now, and you can see that the resistance has changed. So that was my volume up. That's my volume down. So volume up is roughly around 957, 958. Volume down is 997, 998. Previous track is 814. Get that to come back there. And next track is about 899. So that's it. So now that I know what those resistive values are, I'm going to go ahead and just use a program that somebody else built and plug those numbers in there, and then use a keyboard emulator to just transmit whenever it reads in those resistive values that I have shown. So say I want to do a volume up. So it says, okay, I see 958 ohms. I'm going to translate that into the keyboard command to make the volume go up. It's that simple. So now that I know what those values are, I'm just going to go write them down. And then I'm going to flash the program on this Arduino to basically make those keyboard commands go to my Pi. And then all I have to do is connect the Pi with the USB connection coming out of this Arduino, and this Arduino is really going to act as a keyboard. So that's all it's going to do. It's going to emulate a keyboard, and it's going to pretend like it's pressing keyboard presses when I push the buttons on my steering wheel controls. So that's it. Let's see if it works. Okay guys, I want to show you this wiring schematic just so you can see what I'm talking about. And it's obviously up to you to go into your wiring harness and find these wires yourself. But it's not that hard. If you can get your hands on the wiring diagrams and you know a little bit about, electricity, you should be able to figure this out. So I tapped that brown wire, this one right here. That's the red wire that I have going in right here. That's the red wire. That's effectively the one that goes through, you know, it starts up from my head unit, and then it comes through these resistive ladder, and then the output is this one end right here. That's the black wire, which is this wire that I have sitting down there. So I just wanted to show you guys what I was talking about. Okay, I'm back, and all I did was I took the program that somebody else wrote. Again, I didn't write it, I don't take credit for it, and just changed some numbers. So I found somebody else that's already done this once, and I took these values here, and if you remember, I wrote down what my resistance values were here. So that's what I was getting when I wasn't pressing a button at all. That's what I was getting when I pressed volume up. That's what I got when I pressed volume down. Previous track, next track, those are just resistance values. And I populated those values into here, and I kind of just set it a lower bound and an upper bound. So for instance, volume up, as you can see, it's around 958 ohms. So I just said if it's between 945 and 965, then do this, which is the ASCII decimal number for F8, which is the volume up in the program that I'm using. And to get those ASCII numbers, I just went to a website, and it's this right here, cherry tree, MISC, blah, 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 blah. Just type ASCII numbers, decimal, and that's what it is. So if I wanted to press Q, it's 81. That's simple. So that's how that program works. And that's all I changed. Like I said, I took somebody else's code and I just modified it. That's it. Okay, so after a lot of trial and error, I seem to have finally gotten the steering wheel controls working. So I actually went back to the basics. I had to rewire it. And it looks like, interestingly, if you follow the directions on how to wire up an analog input using the official Arduino directions, it'll work fine on a Windows PC, and that's exactly what was happening. So what was happening was I was testing the keyboard on my Windows system. It was working great, and then I'd hook it up to my Arduino, and then it wouldn't work. And it was driving me absolutely insane. So I actually found another YouTuber that has actually done this setup already, and I followed his instructions, and the key difference is that you have to wire a constant 5 volts into it. So with the Windows setup, you basically let the USB input, let that provide the power to the Leonardo. And in my case, with my new setup, I'm actually powering it with a constant 5 volts externally, and I'm just using the 5 volts input from my power supply in my car. So this is the most shameful wiring job that I've ever done. You can see I caked on a bunch of hot glue, but this was basically just to get it working. And in reality, you know, I can actually work with this. It's not going to fall apart on me. I'll probably trim up some of those pins that are sticking up, but I mean, this ugly thing actually does what I need it to do. So right now, you can see I've got a yellow wire that's going into the 5 volts input. That's a constant 5 volts. I then have a ground wire that's coming from my steering wheel controls on the output side of it. The input side of the steering wheel controls goes into the A3 analog input, and it's got the resistor going in between it. So the resistor goes between the ground and, or I'm sorry, the 5 volts and the analog input. And you can actually install the Arduino IDE onto the Raspberry Pi, and this works great because then you can test it on here and get the results. The other crazy thing that I just didn't understand is that if I put it on my Windows machine, I actually get different results. So the way to do this is to actually do all your testing through the Pi. So it ended up being a bit more complex than I expected, but it does work. So I open the sketch, and I go to Tools, and I go to the serial monitor. So now I'm monitoring the serial. So before that was reading 0 with the old wiring. Now that it's reading with the new wiring, so this is with no buttons pressed. I press the back button. I get about 203, 204 ohms. I press the forward button. I get about 119, 120 ohms. Let's see, this is me pressing my steering wheel keys, and it changes the output. So now it's working. Now I can actually convert that into key presses. So what I'm really just going to do is just that anytime that serial value changes, I'm going to say, okay, if it's equal to this value within this range, press this key button. So that's all I'm going to do. I'm going to make some modifications to my program, and then I'm going to upload it and then test it. So finally, we're almost there. All right, I can confirm this thing's finally working. So as you can see, I changed the code. I made it specifically to that section. So when I press the button, what you can see, I set a range. So for volume up, it's 55 to 65. Volume down, 15 to 25. Previous track, 200 to 210, and next track, 115 to 125. So this is what's coming in via serial. So when I press volume up, it detects it, and see it reads the command and then sends it out. And then so that was my previous track, next track, up volume, down volume. And you can see the output actually makes it to the terminal as well. So now that I know that that's working, let me actually test it inside of Android Auto. All right, so I've got Open Auto running, and I have some music up right now. So I'll just go ahead and start playing the music. And then I push change track. Whoa. And it works. So you can see here it picks up the command. Now instead of having volume up and volume down, because I have this rotary controller here to control the volume, I really don't need to control it from here. So what I did is I made volume up, go to Google, navigate to the nearest McDonald's.
Where do you want to go?
Navigate to the nearest McDonald's.
Okay, handing off to Waze.
Here are the search results for McDonald's, 8223 Vineland Avenue,
So,
Orlando,
there you go.
Florida.
So voice works,
32821.
and then I have the other button, it just returns me to home. So steering wheel control is working. I've got just about everything doing what I wanted to do now. I'll just show one last little feature, and then I think we'll wrap this thing up. Okay, so a couple cool things I want to show. First thing I want to show is Android Auto. Wireless Android Auto. So yes, wireless does work. It's got some quirks to it, so I really don't have much use for it, but I know a lot of people would probably think it's a pretty cool feature. So you have to have developer settings in Android Auto, and to get to that, you just type, you just tap, I think it's the menu or something like that. It's really easy. I can't remember. I did it a while ago, but just look it up. But anyways, you enable developer mode, and with that, you start the server. So once the server started, then you have to know the IP address of your systems. So the IP address of my phone is 192.168.0184. So knowing that, now I've got the Headunit server running. No wires connected, as you can see, it's just hanging there. I'm gonna go connect Wi-Fi and type in that IP address. And you only have to do this once. 192.168.0.184, and then once it does that, it'll remember it. So there it is right there. It was pretty instantaneous. So no wires, and I'm connected. So you guys can see it still works. Everything does what it's supposed to do. It's actually quite snappy as well. So one other thing I want to show is Kodi. So if you don't want to use Android Auto and you still want to listen to music, so first of all, you can also do Spotify and YouTube and other apps as well. I don't really care for those. They're kind of cheesy. I'd rather just use those through Android Auto. But again, if you're an iPhone user or somebody else, then that would be a really cool feature. But I like this feature. So if I go to Files and I just have a thumb drive that's in there with some music on it, I go to my music folder and it detects all my music. And then I play song, and it picks up very nicely. And the thing that I like about this is that I can do a lot of the things that you can't normally do with Android Auto. So it's a full-fledged video or music player, and I can set up playlists and do a lot more. So I hope to get to the point to where I just use this to play music and then use Android Auto in case I need navigation or some other tools. So Kodi is very powerful. I can obviously put movies and other stuff like that on there. That's a huge safety risk, so do that at your own risk. But of course, because it's got a full version of Kodi on here, I can do a lot of cool stuff with it. So I just wanted to show that off. I think that's the last thing. So let's just go ahead and recap everything that we've done up to this point, and we'll wrap it up. Okay, so I just want to go ahead and recap everything that I've done up to this point. So from the last video that I did 6 months ago, I put in a new USB hub. I've got a Bluetooth adapter so I can make phone calls directly through the Pi. I've got Open Auto Pro instead of crankshaft. I've got Kodi working. I've got wireless Android Auto working. I've got steering wheel controls working. And I also have the automated shutdown script. So when I shut my car down, it automatically gracefully shuts down the Pi after roughly 58 minutes. And then my car shuts itself down after 1 hour. By shuts itself down, it shuts the Pi down and powers everything off. So I have everything that I think I could possibly think of added as a feature to this thing. I mean, there's a lot going on here, and I realize this is probably a lot to handle for most people, so you might want to do just in bits and pieces. But I hope that by demonstrating everything that this thing can do, that you can really have a legit head unit replacement using a Raspberry Pi and just a hodgepodge of components. I'm really happy with this setup. So if you like this, or if you have any other requests, you know, send me a message and subscribe, please. I'm going to definitely put out more of these videos. So the last thing I'm going to do is I'm going to post another video how I actually in detail did the wiring for the relay. So the delay shutoff relay, that got a bit complicated, and there's more simple solutions, but I will show the video on how I did it just so that you can see how I did the actual 1 hour delay time off. And it's really cool. So that'll be the last thing that I do, and then I think I'll probably move on to another project. At least I say that now. So signing out. Thanks, guys.